So, what are we doing next? We are here for Kojo, right? Anyway, so there are this certain exercises that is shared for Kojo. I'll repeat certain techniques, okay? Those techniques are important. Same way, just like the way we saw for scratch, right? Follow the techniques, it does multiple things. It simplifies what you are trying to think, it reduces the confusion, it solves one problem at a time. And that is why things are really important to do in a certain way. And between that, whatever solution you want to implement is irrespective of that, but try and follow certain practices. And whenever you are teaching this to students, right, get them to focus on those practices as well. It is okay if you don't understand about loops or anything. Spend time on learning the technique. Right? See, धावता सगळी जण. But when you are actually playing a sport, right, there is a specific way to take a stance. There is a specific way to run. Otherwise, you don't win. Right? That is what coaches do. Follow the techniques. Right? Otherwise, there will be a problem. Now, what were the techniques? You saw the scratch techniques, right? We never created the blocks or added the events. What happens when you create it? You unnecessarily run things. If you suddenly put everything under a flag, like green flag hat, the moment you click it, right, everything starts happening. They don't know where to stop. Similarly, if you have a square block, right, you don't know how you are going to trace. Sometimes you can just put line by line items, run everything, and you can then check what is happening. So sometimes those things help. Do not complicate. So those are the techniques. Again, we never went, if you have seen, we never went and added the parameters at the start. We never said like, oh, you know what, this is a circle, right? We need those angles, steps, everything right from the start. We let it go. Then we saw that, okay, it is first drawing the circle. Then we saw, okay, now we need to stop. So since we are rotating by one angle at every point, right? We had to go 360, so that's why we added the angle there. So we added it, and whenever some value was not required, right, we removed it. If you check, we said we will take a start angle and an end angle. We realized that is not going to work. We went ahead and removed those two parameters. Do not leave those things there, they will confuse you. Follow the naming conventions. If you see, there were two things, right, which you were trying to move. There was a square reference and then there was a square. We were trying to move the copy that code from here till there. One was using size. And let's say if you are not standardized on naming convention, you will write one parameter as size with S small, other parameter with size with S capital. And then when you will move things from here till there, right, you will struggle to figure out why it is not working. So get used to the naming conventions. That is why we made it compulsory right in the 6th standard. Scratch does not ask for any of it, but we made it because that helps. Right? Is that clear for everyone? Follow on those practices. All those practices are recorded over there. We added block not because we wanted to do something, but because probably you want to repeat something, or we want to keep passing different parameters to it, like going in a loop or something like that. That is why we created a block. We never said we want to rotate something, so let's create a block. We wanted to rotate something, for that we need to rotate a sprite. If you want to do it continuously, then we need some parameters coming to it, that is when we need a block. Solve one problem at a time. So the same way, when it comes to Kojo, focus is on keyboard. There is no mouse there. Lot of focus goes on keyboard. So keyboard shortcuts and how to write the code over there makes a huge difference. Otherwise you will get confused between where is this curly bracket, where is that curly bracket, which curly bracket is that, which round bracket is that. All those confusions will start happening. Right? And secondly, keep in mind, right, this is your reading area. If this is probably smaller, you have a smaller reading area. If you write a code that goes beyond this reading area, right, it simply makes it difficult to read. And if you can't read it, if you can't understand it, it becomes very cryptic. Then half the time you will just be looking at the screen, trying to figure out what is happening. Alright? Few differences, always keep in mind while coming from scratch to Kojo. Biggest difference is, in scratch, the sprite was both. It was an image that gets shown as well as a pencil. But in case of Scratch or in case of Kojo, turtle is not the sprite. It's just a pencil. It moves and draws something. That is why there is no separate pen extension. By default, you make the turtle move, it will draw. Unless you hop. Okay. Is that clear? So what do we do? Please focus on the shortcuts, the way of things being done. Things will become easier as you get comfortable with it. It will not happen on day one because most of those things don't exist when we deal with Word or Notepad or anything like that. But that is the whole point. Okay? That is why this subject is introduced. Okay? If you want to run, do not make a special effort of going and trying to click on the play button. There is Control Enter. Right? So you can try this forward. So how we are writing this? Understand certain things, right? Do not keep typing like forward, bracket. You are not meant to do that, right? FOR, control space, and you get to see the forward there, right? Press enter. Now don't take a mouse cursor and click on the number of steps. There, it is already selected for you. Directly type what you want to type and press enter. And then control enter. So it's moving. Okay. The first thing. Similarly, if you want to repeat something, this is how it is to be done. Okay, take a look. What we are doing, right? Can somebody guide me? R-E-P, control space, repeat. Now, hold here, okay? See where the selection already is. It's on the count, correct? So I am going to say 4 and I am going to press tab. Take a look at the green line. The second tab is already there. Do not press enter. Okay? Tab. It directly reaches there. Then I am going to say forward. Take a look, okay? 100. The moment I press enter, right? See where the cursor goes. I am just going to press the enter, okay? It goes outside the bracket. Okay? I press enter again. It automatically aligns. Do not press enter and try to press tabs. If at all, we'll see a scenario which will be similar to that, but do not try to use tabs. Okay. And then write. Right? So we need clear, right? So how do we do that? Clear. How did I make it run? Control enter. Okay. Let's take this another example, right? Let's say I already had this forward and forward 100. I'm not pressing anything, I'm just saying enter. Then right. Okay. This will remove. Now I have this already happening. So one part is already happening. Correct? I want to add the repeat later. So the feature doesn't exist over here. It would be available pretty soon. But right now what you can do is, let's say we need to add repeat, right? So say repeat 4. Correct? Then copy paste this or cut it out. How do you cut it out?
Control X.
Control X. Click here. So the moment I clicked inside, right? It was like automatic. It can come either here or here. Don't worry for now. Just click inside. Paste it. And the moment you do that, right? Press Shift Control F. Yeah, format. Shift Control F. Formatting.
So align the script.
So we need a open and close bracket for clear. Is it compulsory?
No. No. You don't need it for height also. If there is a function which does not accept any input, you don't need it.
Sir, how invisible like clear height
Invisible only hides the turtle. Clear hides the turtle. Clear eye. Clear eye hides the turtle and does all the clean slates for you. So it will clear everything. It will get the turtle down to the 0,0. Make it look in the direction 90. So it's facing up, right? That is 90. Another thing to keep in mind, right, is the coordinates are same, right? Positive x is right, positive y is up. Okay? It is very easy to find out, like what the correct coordinates are. But here it basically directly shows you the coordinates. Another major difference between Scratch and Kojo is the angles. In Scratch, right was 90 degrees and clockwise movement, which is right was 90. If you clockwise move 90 degrees down, it would be 180, 270, 360 or 0. In Kojo, it's like the compass that you use in school, or protractor, sorry. What happens when you keep a protractor? Right is 0 and counterclockwise. 90, 180, 270, 360. Alright?
Could you explain
So
it?
instead of right, we can use turn also.
Yes, but they need to give an angle. So we'll see that. Right? We'll see those differences. So in Scratch, the right on the coordinate level, right, is
90.
angle 90. And then it goes clockwise. 90, 180. Oh, so I probably need to hold it this way. Right? So you might be wondering why am I going counterclockwise, right? So 90. 90 clockwise, right? 90, 180, 270, 360. In Kojo, it is as if you are holding a protractor, right? So 0 and then counterclockwise. 0, 90, 180, 270, 360. So if you are trying to do something like what we did just now, right, in Scratch, and if you are trying to same angles, right, imagine it will face it the other direction. Okay, but we'll see how difficult what we did now, right, becomes in Kojo, whether it makes it easy or it makes it difficult. Alright, good enough? Similarly, let's say if you are dealing with gradients, right, here is what we can do. Okay, whenever gradient is asked, let's say we are saying Cm dot, right, linear gradient, do not use the same technique. It does basically the same thing where you can press, then go. But take a look at the problem here. It goes beyond the screen margin, right? What you do is click outside first and then start organizing it. So take a look at what I am doing. Okay, Cm dot linear gradient. Okay, I am going to click there and I am going to arrange it. So I am clicking just before this x1, right, and I am going to get it down. Then I will keep x1 and y1 on the same level first. Then comes c1, which is the color one. Then x2 and y2, which is the other point. Then c2, and then finally end it with cyclic. Alright? Should we do that again?
Yes, sir.
Cm dot, I am not typing the whole thing. Linear gradient. Okay. Press enter. and get this x1 onwards, like the first parameter onwards thing down. Makes it easier to read, right? X1 and y1 are a single position value. First point, they are together. It is not like x1 means something and y1 means something. It is the same data, just with two numbers, right? So x1 and y1 stays on one line. This c1 is not the position, it's the color. So it gets the second line. Again, x2 and y2 are correct. Okay. Then c2 is a color, and cyclic is a different property altogether. Right? So it's neither a color. So everything x1, y1 is the first position. x2, y2 is the second position. Okay. c1, c2 are colors. Notice one thing in this setup, right? There are no commas here on the left side. All the commas always come on the right side. Notice that, right? Okay, and then you can double click on each of the values and start changing them. Take an effort to double click on them, the whole thing gets selected. Do not do something like this.
How to take exact value x1? Randomly you can enter any value.
We will see that. How we will do each of the coding part we will see. I am talking about the techniques. Okay. Similarly, there could be like many, right? Cm dot linear multiple gradient is also there. It's slightly bigger. The steps to take there, right, is almost similar. Enter. x1 and y1 are first point, correct? So that gets x2 and y2 is the second point. Okay. Distribution is third. Colors is after that, and cyclic. Okay? See how the data is organized. Again, there are no commas or in the left side, but all the commas are on the right side. Okay? And if you want to change it, double click on them. And then you can start entering the value. Why am I saying that? What happens if you click and start deleting one by one? Sometimes we are a little too excited, we'll go like this. And then we'll say, oh, we'll forget that there was white. This way you cannot. The moment you do and type some value, right? Only that one changes, it does not select the comma. Right?
So distribution is what?
Those details later.
So you double click.
Double click on each one. I am keeping this particular section only as techniques. So in the YouTube video, right, it could be like kept in that sequence. Otherwise the whole thing gets mixed up. She is smiling. Okay, let's say we are working on functions. So how do we write any function? How do we write any function? Define def. Okay. Write the name. So let's say, what should we say? Square. Okay. Always put the curly brackets. Always put the curly brackets. Because at this point, right, it is easy to identify that the curly brackets, where the curly brackets are. And then it gets confusing when you suddenly need to introduce some parameters. Okay? Equal to, take a look at the process, okay? What am I doing? Df, square, curly brackets, put both together, equal to, sorry, rounded. My bad. We'll correct that in the YouTube one. We'll put a special description. Okay. Now comes the curly bracket. Okay. Enter. The second curly bracket comes automatically. Okay. Should we do that again? Who will tell me? Name of the function. Round brackets equal to
Curly bracket.
curly bracket open, enter. Okay. And once you have done this part, right, press Shift Control F. As in, once you are done after typing what you want to type inside, right, it automatically leaves the spaces here. Makes it easier to read. So let us implement the square. DEF square round brackets equal to curly brackets, enter, forward 100, enter. The same step happens, okay? Right, enter, Shift Control F. Okay? Then come outside and you can call it. Okay, it didn't draw the square. So what should we do? Repeat. Take a look at this, okay? Take a look at this properly. Repeat for tab. Okay. Then Control X, V, Shift Control F. Control
Enter.
Okay. Do not introduce parameters because you saw them in the video or the photo of the code from the projector screen. Take it because you want something to be changing. So this square is completely fine for me. But if I want my size to be changing, that is, I want this 100 to be variable. It could be 100 today, 50 tomorrow, whatsoever, right? That is when I need the parameter. Okay? And the correct way to do that, right? So that the compiler can tell you have forgotten something. The other way is horrible. Compiler does not tell you that you have forgotten something, and then you break your head to figure out what you have forgotten. So I will tell you wrong way first, the right way second. Okay? Wrong way first is I go here and say size :long. Long. Now why is this a wrong way? Now that's because you will say this, you will get an error saying that you have not specified anything. The student will come here, he will say 100 or 50, let us say. He will press Control Enter and he will say it is not drawing at 50.
We have not used.
So right now compiler is telling him everything is fine. But he is now wondering, okay, then he will try and make it 500 and yet it is drawing for 100 only.
Because it's a 100.
Not used.
See, right now it's a small code, right? Moment you have a bigger code, right, you will not realize where you have forgotten. So, let's do the correct way. Let's remove this. Let's remove this. Let's make this 100. Okay? First thing you need to do is type that here. Okay? So we will say size. Now the moment I say Control Enter, right, compiler tells me you have written something but you are not passing it. So you need to take that as an input, where the input comes from within these round brackets, right? So I will say size :long. Okay. If I need more, I will put comma and keep saying that. We will say that as a reference. Now again, if I say Control Enter, compiler again tells me this is the point you have not added the value. So I will go there and say 100. Now it works.
So what is that size?
Long is like an integer. 0, 1, 2, they are not fractional numbers, right? 0, 1. There is no 1.1. 0, 1. They are exact numbers. Okay. Those are longs. So if you want to know, if you want the exact numbers, go for long. 1, 2, 3, like that. Go for long. Okay. If you want to go for something like 1.5, 1.1, go for double. D-O-U-B-L-E. D-O-U-B-L-E. Double. D capital. Okay. And if you want to go for a name or anything like that, go for a string. S-T-R-I-N.
And for int?
Int is long. I mean, int is there, but then I'll have to explain when to use int, when to use long. It is better to just use long. Text is string.
Just want to display a message.
Yeah, it's string. I'll show it here.
So there is no need of 90 using next to right, no?
No, there
By
is no
default,
need. 90 is default.
90 only.
90 is default.
So right,
90 is default.
right, left, we can just go for using without 90.
But it is better to write it. You will see why. It is always better to be explicit. Okay? Float is equal to double. But I don't want to get into what is that int, what is that long, why is it called a float, why is it called double.
Exponential.
Exponential is technically double, but let's not go there. You will have a value calculated as some number there. Okay. All right. Good enough. So always remember one thing, right? Only the exact numbers can be comfortably compared. 0 equal to 0 can only be compared if it is an exact number, that is long. If you want to use double, the safest comparison is either greater than or equal to. Do not try for, greater than or less than. Do not try for equal to. Okay, you will always get confused why that is. We will see where those applications come into picture. Everyone clear? So we can try something like this now, that so def greet. Okay. So I am breaking my own rule. Def greet brackets equal to curly bracket open, enter, and here I am going to now say write. Correct? So I need autocomplete this thing. Right? Directly comes here. Put a quote. And maybe you can write your name there. Okay. Shift Control F. And now, if I say greet, I have a name there. But I want that name to come from any possible sources. Correct? I want this name to come from any possible sources. So how should I do that? Like it could be hello Anay, hello Mayur, like whatsoever. So obviously if that is the case, this Anay is a variable here, right? So I need to write a variable here. How will I do that? So understand one thing, okay? This is within a string.
Quotes.
Variable without.
Yeah, and so one way to do that, right, is take a look at this, okay? I need to have a variable here, right? So possibly, if I just say name here, right, what is it going to do? It's going to say hello name. It does not become a variable there. You have to say that this name is coming from an input. This name is not a fixed value, right? So the way to do that is before this first quote, right, type S and before the name put dollar.
Becomes a variable.
Becomes the variable. Okay. Now, if you say control enter, it cries. What does it say? Is not found. Name is not defined. Why? Because I have not written it here. So now I am going to say name colon string. Okay. Control enter. And now it is telling me see, I have not passed the value in grid. So here I can say Anay. Now it says hello Anay. Okay. If I say here, it will say hello. Value. Yeah. It is in the quotes. This has to be in the quotes. Because if you don't put it in the quote, right? This Mayur becomes a variable it is trying to search for. Take a look. It will say Mayur is not defined. That is why it needs to be in the quote. Where? Where you didn't put the quote? Let me see.
In the Greek, she did not put the quote.
Where?
In the Greek, when you are calling the function,
Yeah.
she did not put the quote.
Okay, so that was an interesting thing. Let me try and tell you what happened there. So, this quote was not put, but so was this. So, if you try to run this, what it says is this variable is not found, but it does not say this Mayur was not found. Why? Because it is trying to compile it top to bottom. When it tries to compile grid, it realizes that this is incomplete. So what it tries to do, it gives you error here and stops. Now the moment you give the value here, name colon string, and if you try to compile, then it will go to the next line and say the Mayur is not there. Okay. Always when you are running, right, keep a eye here, okay, in the output window, because if there is an error, right, the previous output does not go away, giving you an impression that it is working fine. But in all reality, it is failing below.
But it should go no, sir, because of clear.
No, it didn't compile, right? So the first process is it has to compile the code and then it is going to execute it. But the compilation failed because there was an error. It did not understand what you are trying to say, so it failed. It never ran it. Because it did not run it, the clear did not get executed.
So it is compiling it.
Okay? Is this good enough? Are all the techniques fine? Give a time for the keyboard shortcuts. Everyone remembers? When to use tab, when to use enter, control shift, F. Correct? Okay? So, last time we did turtles. Right? Turtles all the way down. Everyone's comfortable with turtles? Okay? Today we are doing pictures. Okay, that was the whole topic for the today's session. And this is where Kojo goes completely different. So you had a scratch way of doing things. And with scratch way of doing things, you have a scratch way of getting problems also. So today we are going to do pictures. Now what is a picture? Okay? Try and understand this. This is the most part, okay? This is the theory. We don't have a theory, but it's important here. What was a turtle? Turtle was a pencil. That is, you have a fixed page. Understand this, okay? You have a fixed page, and in that fixed page, you have a moving. So the page remains fixed. You have a moving pencil. You can choose to move the pencil down, move the pencil up, but the pencil moves. The page doesn't move. The pencil moves. Okay? You need a slightly different way of looking at the whole structure when it comes to pictures. Okay? And why is it different? It's because in pictures there is no pencil. Because you have got a picture. If you already have a picture, why do you need a pencil? But where is that picture? That picture is on a transparency. Okay? And the picture doesn't move. The whole transparency moves. Strange enough? Getting the idea? So imagine that there is this page, right? Let's say this whole thing is a page. If you want to write something, you are not going to write on the page. You are going to write on the transparency and you will keep the transparency on it. Okay? If you want to move that text on the right, you will not write the text on the right. You will move the transparency on the right. Because there is no pencil. Right? You have got only transparencies. Then you can keep your transparencies on top of each other. And after keeping your transparency on top of each other, right, you can move one transparency behind it. Making sense? And if you can move a transparency, you can move a set of transparencies also. You can rotate the transparencies also. But when it comes to rotation, understand one thing, whenever something rotates, right, there is always a center point. So all the transparencies, no matter where they are, rotates only around the center of the screen. Confusing? We'll probably show something, okay? So take a look at this. Can I take this graph paper? Watch this, okay? Now audible?
Yes.
Okay. This is my transparency. At least imagine like. So I've written something. Can I write something on this? Anyone has a pen? But I'm going to draw a square. Okay? I'm going to draw a big square on it. From its center. Okay?
I have one more sister.
Okay.
You can take it.
No, that's fine. So, is this visible?
Yes.
Okay, so there is a square and this is the center of the square. So square also has a center. The square has a center. And that is on the transparency. Okay. So, when it is first put, the square of the drawing, right, or the transparency will be matched to the square of the screen. Fine? So if I am rotating at this point, the rotation always happens from the center of the screen. So see how it is rotating. Correct? The square is rotating around its own center. But let us say, if I move the square a bit towards right, You don't move a square to the right, you move the whole transparency to the right. Right? See what happens, okay? Now if I rotate, what will happen? So the whole transparency rotates, you don't rotate a square. And rotation happens around the center of the screen. So center of the screen does not change. But see how the square is now moving. Make sense? Okay? So is the other operation which we'll look later, and that is scaling. Which is, now this is something that is not directly possible with the pencil. Right? Which is making the image bigger or smaller. Making any picture bigger or smaller. Which means now you can draw one picture or one house and place it one after the other, getting smaller, you get the whole scenery. Right? So what happens with the picture is you never have at the end of a picture where a turtle is looking somewhere else. So remember we were drawing all of that in the morning, and half the time what we were struggling on? Moving the turtle back to its original facing. So we had to calculate those lot of different angles and all that kind of stuff, right? So those things go away. Once you have a picture in front of you, that is what you have. You may move the picture wherever you want. Correct? But you only move the picture. That is all it is. And then there are obviously many different things that you can do with. So the way you can, or the complexity that you can introduce there, right, is quite different. But understand the basic thing, okay? It's no longer a pencil. It is not a pencil. It is a transparency on which you draw, and you do not move or rotate the drawing. You move or rotate the whole transparency. And you move and rotate the whole transparency around center of the screen. Good enough? Okay, any confusion till now? Yes? So let us see some examples, okay, going forward. Now one thing that directly happens with, so we will first do, then we will again see techniques around it. Okay, so both are important. Because if you don't have the techniques going around, right, you will start getting confused at every point. So, how do you draw a picture? The simplest way of drawing a picture. Let us draw a square. How we used to draw a square?
13.
Correct. Let us first draw a normal square. So we do it by saying, repeat, 4, tab, forward, let's say 100, enter, right, and 90. Alright? The thing is, this happens directly. It gets directly executed. Okay? But a picture is not a command, it is a value. What does that mean? Command is something that gets directly executed. It's like I am there on the board with a pen and you are telling me forward, right, forward, right, forward, right, forward, right. But a value is like, you are sitting there with a projector. I have a transparency. You ask me to do something. I do it on the transparency. Do you see anything on the screen? Obviously, because I have to give that value to you, then only you will put that value on the projector, and that is when you will see it. You will see the difference now. So I am going to build a value. So the value is, right? How do you define values? Well. So define is def, value is well. So VAL square equals PIC, correct? Do you see a picture here? So that you press enter, put a curly bracket, enter. Just like how you are defining a function now. Now I'll move the whole code, Control X, and paste it inside a picture. Now obviously the whole formatting is gone wrong. That is why whenever I paste something, I am going to do Shift Control F. Now if I press Control Enter, nothing happens. Because I made a transparency and kept it with me. If I want this to not just stay with me, I have to give it to somebody in order to draw it. So I'll say draw, right? So draw is a function, okay? Draw, and then put the square in it. Now I have a square. Okay? All right? Good enough? Now, why is that square in that position?
It always draw at the same.
So, let us say if I move the turtle somewhere else, right? Let's say if I say jump to, right? There is this jump to here, right? And let's say if I give this location here, which is minus 288, 163. Okay, so I'll say minus 288 tab. It goes to the second parameter automatically. Tab 163, enter. So what will happen now? Where is the turtle going to be? By the way, minus 283, 163 is here. Where is the turtle going to be and where is the drawing going to be? Turtle will go here, but the drawing will remain here. See. See that? Now it would have made a difference if I had put this inside the picture. Okay. So if I put this inside the picture, then it will draw the square on top. Okay? Make sense? Why is this? Because before, inside the picture, before drawing the square, I changed the turtle to that point. But now, the main turtle is only at the center. Because nobody touched the main turtle. Picture is a picture. I have already drawn it. But don't do this. Don't do picture by using everything as turtle. Correct? So up till now this is fine. Don't do this. So how do we move this square somewhere else? We have a square here. How do we move this square somewhere else? By the way, what is your version of Kojo? Is it 2.9.23?
2.9.21.
Okay. Start downloading the latest one. That is important. Everyone has a net access? 93? Okay. Who doesn't have 2.9.93? Sorry, 23. 22. Download. Net is not working? Ma'am, net is not working. Oops. Okay, doesn't matter. We can still work. Okay, because there was an update. which I'll mention, okay, which once you update, right, will work directly. But how do we move the square somewhere else? We need to move a transparency, right? How do we move a transparency?
Update the version, do we need to reinstall?
Yeah, reinstall. So let us say we want to move the square. So move operation, right, is called a translation. You translate by a given x value and a given y value. Okay? Given x value and a given y value. So let us say changed square is, what is the changed square? We want to move it, right? So we will say change square is a square, okay, that's translated to any point you mention. Let us say we want this to be translated here. What is this point? Obviously 100 by 100, right? 100, tab 100, enter. Do not click. Now obviously if I run this, square is going to be there, turtle is also going to be there, because what am I drawing?
Change square.
I am not drawing a change square. Okay. So I will copy the change square. I'll go to draw and I'll ask you to draw a change square. Now if I press Ctrl Enter, see, it's moved. Okay.
You have to create a value here. You can't directly say square dot.
Yeah, you can. That is also possible. So you can very well go here inside this draw and say change square dot that's translated to, let's say, minus 100 by 100. Correct? So it will come the other way now. Sorry, this should have been a square. Yeah? Minus 100 by 100. Does that make sense?
So that works fine. That is working.
Yeah, that is good. Keep in mind, whenever you do something of this sort, right, the whole transparency itself gets changed. So it's a new value. Your earlier square is still at the center. This is a different square. You are not changing the earlier square. Keep that in mind. Okay. What I mean by that is you have this square dot that's translated, right? If I again say draw square, this square will be at the center. So just because on this line you asked the square to get translated, it did not change the transparency of the square. Square is at the position where it was. You basically simply said, now make a new transparency where the square is at a new position. Make sense? So you keep building a value, and those values never get drawn till you actually put it on a projector. Now, one best thing about Kojo, right, is if you really wanted to experiment with values, right, in Scratch, you had to like sort of create a variable. So that was the problem with Kojo, Scratch. Whatever you want to do, right, some nice good stuff, you always have to define a variable. You don't have to do it here. Let's say I want to see how things move when I change this 100 value, right? you can just control and click on the value. And you see you get this slider. And as you change this, right? You see that? It's changing underneath the number. But we are not using it, right? Control and click on the number. Control, click on the number. And you get the slider. See? See? And as you try it out, right? It keeps moving. Control. Control and click on the number. If that doesn't work, you can say right click. Is there a separate shortcut for that? Control click doesn't work. Where you are clicking? You are clicking on draw or you are clicking on the chain square? Is the chain square being drawn?
Yes.
It's not changing.
It's not showing that.
There is another way to do the same thing. Let's say sometimes putting the draw outside, right, looks weird. So you can do one more thing. Like, having this draw outside looks weird. Okay? So the other way of doing that is I'll simply say square. Take a look at this, okay? Square, and see the way I'm doing it. I'll press enter, tab, dot, draw. So it will draw the square for me. And whatever I want to do, right, I'll say between the square and between this draw. So square, tab, dot, that's translated 50, 50. See? So I don't need to explicitly say draw before. Do try this out.
Now it's coming.
Shortcuts.
That control click. Now it's working.
What happened?
Now it is working.
Yeah, but how?
Sir, but if it is not control shift आणि format जर बांधून आणली जाल्यार there is a error.
Because something might not have. Always keep a practice of formatting the code, okay? Whenever you do any copy paste or anything, right? Always use formatting. Keep that as a habit. You copy paste something, shift control F. It doesn't harm to do that 10 times. I can say shift control F, tap, 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 doesn't harm. Say it n number of times. But it always cleans the code. Okay? Everyone got this? Right? Let's do rotation. So instead of saying that's translated, so here I will simply say square. And instead of saying that's translated, I will say that's rotated. And I can give an angle. So 90, remember, all the angles are, or rather 45, all the angles are, if I say 0, as it is, because I didn't rotate it. I am going to say control, click. Control click on the number. Okay. And as I increase the value, how does the angles work in Kojo? How does the angles work in Kojo? Counterclockwise. So if I increase the angle, which direction will it rotate? Counterclockwise. So as I am increasing the number, say, are you noticing it? And it is drawing it around the, it is rotating it around the center. Right now it is not explicitly obvious that it is rotating around the center of the screen, but if I sort of move this first, let us get this back 0 and let us first translate. So I will say dot that's translated. So I will move it slightly forward by 100 and y I will keep as 0. So it is towards the right, correct? Now if I start increasing the angle, see how it is rotating, okay? If I now start increasing the angle, see how it is rotating. Are you observing it? Rotations happen around the center of the screen. So let us say if this is not what you wanted the square to be rotated and then moved, what will you do? First rotate and then move. But if you move and then rotate, right, the whole thing gets rotated. At the very heart of it, right, this is what pictures are. Difficult? Okay, I'll make it difficult. If this is not difficult, I'll make it difficult in some other way. So one particular thing, right, before we break for lunch. Is lunch there? Okay. So, one particular thing before we break. Why are we using repeat now? No, I mean, in Scratch we said don't use repeat forever, right? Here we are using repeat. Why? That would have been the reason in Scratch also, right? Why here? See, because the curriculum is putting a special effort, right, to not use variables. Why is curriculum saying not use variables? Like in C, Java we have been using, right? How many of you have learned C? Java or whatever? Okay. If you have learned it, right, tell me how many of you have seen something like this? What does this mean? Write something like this, show it to your maths teacher, she'll fail you. Because if I write it as an equation, right, you know what this means? You know what your maths teacher is going to do? Why? Because the x and x will cancel and 1 becomes equal to 0. So your maths teacher is going to say you are going to get 0. So computationally it is wrong. If anybody writes something like this, right, computationally it is wrong. So we are not using a variable. This is what the variables are going to do to you. Secondly, variables unnecessarily confuse you because you declare them at one point and then use them somewhere else or change them somewhere else. It is like जो बाहर गया था वो राजू का पप्पा था, जो वापस आया वो पिंकी का पप्पा था. Because the variable got changed in between. You would want the one who goes out comes in, right? not somebody else coming inside the house in the same dress, right? Or you, so So there is this weird story, right? I'll narrate an incident which actually happened. So somebody wanted to sell the car. So this is called as difference in the execution, okay? Between you define something at one point, use it at some other point, anything can happen in between without you realizing. So what happened? Anybody tried selling the car? No? So I didn't do it, okay? So when you try and sell the car, right, you go to the, let's say, or the Cars 24 or like, Maruti, what you call it, True Value, right? You take your car there, they are going to analyze your car, and then they are going to say, okay, this is the value of your car. Whenever you get it, we'll give this value to you. Okay? So what do? You take your car, they'll pay you that much. Okay. So what happened in this particular incident was, they first got the car valued and they said we'll get the car tomorrow. The dealer said okay. And when the car got valued, they mentioned some rate. They analyzed the whole thing and they mentioned some price. You will get, whenever you will get this car, right, you will get this price. Okay. So they got the value, they got the car next time, like in the next day. Dealer paid them. They got the new car home. And in the evening, they received a call from the dealer. See, when you got the car for the inspection, right, they had a newer tires. When you got them to, when you gave them to us, right, suddenly they have old tires. So the earlier inspection does not hold true. Come back and pay the remaining amount. The variables got changed and nobody realized. So essentially what happened was, they had just replaced the tires. So what they did was, when they unknowingly, they probably thought, why give the new tires away, right? So they replaced it with the old tires and gave the whole car back. Obviously the dealer should have done the due diligence. But it didn't, because they thought variables won't change. But guess what? The variables changed and 1 became equal to 0. Okay, just like that. So, somewhere down the line, right, variables get confusing. So we try to avoid variables. Unfortunately, in Scratch, there are no better ways to avoid variables at all. So what is the problem with the loops? Let us say if you want to do something like changing the angle, right? If you rotate, changing the angle or changing the position, how will you do that with repeat? After every step you need to change the next value, right, that you are reading for the angle should be different. How will you do that? You will need to declare a variable, set it to some value, then for every repeat, right, you will need to draw it for that particular value, and then at the end assign the new value to the variable. So something exactly like this, x is equal to x plus 1. You will say set x to operator x plus 1. So that is confusing, right? We will do something very similar here, but let us try doing it in a different way, right? So let us say drawing a square is fine. You have a square, you have a different size, right? You want to just draw it 10 times. So we need to see that the value being changed. How does the value changes? Without using a variable. How can we do that? So let's take a look, right? Let's first draw a square. Again, for now I am doing it with turtle. Okay? So let's first draw a square. Or should we do it with pictures? Let's do it with pictures. Okay, let's draw it with pictures. So what we are going to do is, let's say def or well, doesn't matter. Square is picture, right? Curly bracket, enter, it auto completes. Then I will say repeat, enter, 4. Okay, tab, forward, 100, fine. as a picture. Okay? Square dot draw. Is this fine? What I want to do is I want to slowly increase its size. Right? So something like this. Square dot, that's scaled. So I want to increase it. Okay? That's scaled by 1.1. Okay? 1.1 dot draw. See how it is drawing. Or rather I'll say 1.5, let's say. Can't, okay. So instead of the square, right, instead of using well, always try and use def. Okay, that's slightly better. Def is always safe. So now you will have something like this going around. So 1.1. Okay. Now I want to do 1.2. I want to do 1.3. Whatever, 10 times, 5 times, 6 times, whatever. How would I do that? Everyone got what I want to do? So this is
that is a error.
no, that was the previous error. Keep in mind, okay, we changed the square to def instead of well.
So for that error was for well.
That was because it was well. Yeah. Got it? This we need to do 3 times using repeat. Okay? So how will we do this 3 times? How would we do this 3 times?
In 3.1.
So we need a range going from 0 to 3, right? Let us see what happens in a normal way, okay? Let us define a variable. Scala allows you to define variables, by the way, okay? The way you do that is like this. Take a look, okay? The normal way. The way we would do it with variables. And then we will think about not doing it with variables. We will go basically like this. You will say where for variable, define def, value, val, variable var. Okay? So where counter is equal to 0. Start with that. Okay? And now we are going to say repeat, this is 3 times or 4 times, right? Repeat for tab. We would say we need to find the scale value, right? So we will say well scale is counter divided by 10. 10.0. Similarly here also we will say 0.0. Because we don't want to do with exact values, right? These are fractions. We want something like 0.1, 0.2, 0.3. And then we will add it to the default scale, which is 1. So so scale is 1.0 plus counter divided by 10. And then we would say square dot that's scaled by scale dot draw. Now if I remove this and try to run it, right, it should produce the same output. But what happened?
So can we use square draw dot scale?
What is that?
Draw scale.
What happened to draw scale? So I think the scale is not changing. Let us see what is happening to the scale. So let's say print scale and see what is coming. So So 1.0. So it is becoming 1.01. Sorry, 1.0. 1.0. Why everything is 1.0, 1.0, 1.0? Why is that? This counter is
Sir, value
okay.
of scale.
Nobody changed the counter. You saw the problem? The first problem with the variable. You have to remember to change it. Correct? So towards the end, we did not change the counter. Counter is equal to counter plus 1. So this is that x is equal to x plus 1. So first we forgot to change it. Then we are changing it in such a way that I can prove that 1 is equal to 0. Okay. Alright? You got the same output now. Using variables. Don't copy this. We'll need to do it without variables. How will we do it without variables? The problem was, see the biggest problem between this and this, right, is this value is defined here. Somebody somewhere down the line, right, can go ahead and say this counter is equal to 10. And then suddenly you have something else only. We don't want that to happen. We'll do the exact same thing without using variables. And for that, we use what is called as a range. So if you say repeat, right, just try REP and press Ctrl Enter. And then you will say repeat for. And it takes a sequence. Right? You see repeat and then repeat for. Correct? So they have given that signature there. So let us try repeat for. And we go from 0 to how much? 1, 1.1, 1.2, 1.3, correct? So 0 to 3. So we will say repeat for. We have to put a sequence. And the sequence is 0 to 3. Tab. This is counter tab. And now we can say well scale is equal to counter plus scale is equal to what? We need that, right? 1.0 plus counter divided by 10.0. There are no variables here now. So we will say square dot that scale. Take a look at this, okay? Scale dot draw. I don't need to worry about returning or changing the variable now. If I draw it, it gives the same output. Make sense? If you are wondering what this is, right? In case you are wondering what this is, that's a function which accepts a parameter called counter. Exactly like what we used to do with by defining a block, right? And taking that angle as the parameter or anything like that. This is exactly what it is. This is the input. And this is the range. Essentially you are telling Scala, call this function from here till here for every value of this range, 0 to 3. You can change by how much this value is increasing as well. So we can tomorrow say 10. There are lots, but we want to skip something in between. So I want to start with 0, then do 2, 4, 6. How would we do that? I'll say by 2. So change every value by 2. 0, 2, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10. That is the point it stops. No, pen is not increased. It's just drawing it over and over there. All other thicknesses are the same, only bottom. Drawing over it again and again. It's getting scaled, right, in this particular direction. I want to make this concentric squares. How big change would that be? Concentric squares. So they are all expanding this way, right? I want all of them to like start with the center, then the other one, the other one. How big change would that be? And how much of the code will change? We had that problem, right, in the morning, getting the square in the center. How long it took us to get the code in the square in the center in the morning?
No, not the, just the square in the center.
5 minutes? Yeah, 5 minutes. You want to see how long it will take now? See, all I need to do is make sure this square is at the center. How would I do that? I'll simply get this one level down. Okay? And before it is scaled, I have to transition it in the center. What is the default size? 100, right? So by how much will I need to move it? 50-50. 50 left, 50 down. That's translated. So because of this change, right? So that's translated. See, minus 50 on the x side, left. So this is the square, right? See, this is the turtle, this is the center of the screen. This is the square. This I have to move. Minus 50 left, minus 50 down. So they are both minus minus. Right? Minus 50, minus 50. Control enter, everything at the center. Simple, right? Don't move the turtle here or there and all that kind of stuff. All of it is gone.
In one line, the last.
Why if you write square dot, that's translated, and then again square dot, that's scale. that case it doesn't run.
No, it is not square dot that's translated. It is square dot that's translated dot that scale. It's this way.
It's one statement.
It's one statement. You translate it and then scale it. It's not, there are not two squares. You have a square, you then have a translated square, that whole thing is then scaled.
But still, if we observe that the inner square is thickness is less. Than
Yeah, because it is getting scaled, right?
Okay. Okay. Got it.
Everything is getting scaled, even the thickness. So if you increase the value now by, let's say, 100, if I start rotating, this point remains common. Now you rotate the whole thing. So can you imagine how this would rotate? This remains common, right? It rotates like this. It won't rotate from this point. It rotates fully. The whole circle will go like this. Well, this point not changing. So it would feel more like this is a graph paper, right? It will feel more like it's like this, correct? It will go more like this. This point won't change. Correct? Similarly, that is the whole point being the center, okay? That point cannot change. That point simply cannot change. So if you try to scale it, now what does it mean scale? By how much you are multiplying it. So scale of 1 is what it is. Scale of 2 is double, which means there is 400 here, right? So if I scale this by 2, this point remains where it is. This point will come to 400. This point will go to 400, and similarly this point will go to 400, 400. Because this point cannot change. Make sense? Clear? Any confusion here? No, right? Any confusion, sir? No, right? Good enough? Okay. So, you want to try this out? You want to see how it goes? So I have a square and I want to say square dot that's translated. And if I say 100, 0, see, it goes by 100. That is the point which is at 0, 0 earlier, right, has shifted to 100. Okay. And remember, it is not the square which is moving, okay? This is very, very important to understand. The square is not moving. The whole slide is moving. Similarly, let's say this was not translated, it was that scale, and the factor, right? Factor of 1 means nothing. It's the same thing. Factor of 2 would be double. It's gone to 400. Those points have gone to 400. And factor of 0.5 means what? 50%. Right? It is same as saying 1 by 2, which is half. Which is, so the thing that happened now is both 1 and 2, right, are fixed values. And if you divide the fixed value, you cannot divide 1 by 2, it becomes 0. Right? So that was the problem here. So if you want to avoid this, say 1.0 divided by 2.0, and now this will make it 0.5. They are fractions. So what happened? Not very, very visible. Maybe I'll just increase the stroke size will be visible. But whatever was at 200, right? this point does not change. Whatever is 200 has come down to 100 now. Okay. And if I take this away, it's what? Make sense? Everyone understood what is happening? Now let us quickly talk about filling the colors. How do you fill the color? Filling the color could be anywhere, right? So essentially if I want to fill the color to something else, I'll say that's filled with orange, and that's filled with orange. Okay? If you want to change the border color, so border, right? What do graphics artists say? They don't say it a border. When they use a pencil, what do they say? Do they say like I have drawn a border with a pencil? No, they don't say outline. Outline is what engineers. It's called strokes. Pencil strokes, right? So it's not technically a border, it's basically what you have moved with your pencil, right? So that's a stroke. So that's stroke color and stroke size. Stroke color is what that color is. So here I can say blue and it gets colored with blue, and if I say that's stroke size, this is where it gets interesting. Take a look at what we have done. Okay? If I say 10, so when you give a stroke, right, always remember one thing, and this will come to bite us again in SVG. Okay? Did you notice something? Half the stroke width is inside the border, half the stroke width is outside the border. Did you notice it? See, huh? If I just say stroke size 1, right? See, this is the border, correct? And 25 is somewhere here. This is 0, this is 50, 25 is here. But if I make it 50, something else. So if I make it 50, and you might notice that there is 25 here, 25 outside. Okay.
So what about rounded edge?
Yeah, because it sort of held the pencil and went about it, right? So it got a rounded. That's rounded edge for free. Is this clear? Now what I will do is I will remove the stroke color, but I will say that's stroke size, let's say 10. Okay? Fine. Good, yeah. Shift Control F. Now do you know where the center is for the square? Do you know where the center for the square is? Square. Center of the square. It's at 100, right?
Yeah.
So it's somewhere around here. Let us say, now we want to make it bigger. It is like start from the center and grow all the way equally on all the sides. What do we need to do? See, when it was growing from this point, right? If I slowly starts increasing its size, it will only move forward. Take a look. So, as I increase the size, right, see, it never fills up this side. Can you see it? It only goes the other way around. That is, the center keeps moving further here, center of the square, but this center does not change. So let us say if you want to expand all the way, what should we do? You have to get the square in the center before you scale it. You have to get the square in the center. So how will you do this? Before you say that's scaled, correct. That's translated. Now take a look at this, okay? It has to move left because see this center, right, is towards center of the square is towards the right and above. Center of the square is towards the right and above the center of the screen. Am I right? So if I want to get this towards the center, I have to exactly say opposite of what I have said. We have to get it left and below, which is both negative values, left and below. So minus 100 because half of 200, or rather I should say 200 by 2, or even better, into 0.5, right? And the other one is minus 200 into 0.5. That makes it in the center. And now if I change the value, so, can you see it? Now it is expanding in all directions. So understand the concept of the center very well. Okay? Do not forget the center. You can forget the state government but not the center government. Okay, so we discussed this some time back, but let us try it again. Okay, if I said 1 divided by 2, the whole thing disappears. Why?
0.
Yeah, but why is 1 divided by 2 0?
It's not a fraction.
It's not a fraction. You are not asking for a fraction. You said 1, which is the whole number. 2, which is the whole number.
It will give a whole.
Correct? So basically, it's like asking one unbreakable thing, दोन जणांनी वाटून जाय. कशें जातले? दोन भाव आसात. एक अशी गोष्ट आसा जी तुटूंक शकना. ती दोन जणांनी वाटूंक जाय. कशें करप? Finally, both of them decide कोणाकूच नाका चल. So ती वस्तू कोणाकूच मेळना. So it is 0. So here they are basically saying, okay, या साइडीन कितली उडू, त्या साइडीन कितली उडू. Finally सगळें म्हणटा नाकाच चल. So स्क्रीनीचेर कांयच येना. So in order to make it possible 1 divided by 2, you have to define them to be breakable. That is, you have to tell them that it has units before it and after it. So you can say 1.0 divided by 2, and then you have half the size. Better still, you can say both of them are doubles. Okay? So, stroke size, stroke colored, filled with, translated, scale. You can actually change the scale operators together. Okay? So, first we translated in the center, then we scaled it, then we can again shift it to 200. So, let us say here something like this, and then we again say that's translated, correct? 200 into 0.5, 200 into 0.5, because we are again moving it back where it was. And now if you try and change the scale value, right? See, It's expanding while this point remaining constant, 200, 200. So if you want to do something around the center point of the square, first get the square's center point to the screen center point, scale and rotate, and then get the square back to where it was. That is what you need to do, like this. First, get the square's center point to the screen center point, scale or rotate, and then move the square to back to the position where it was. Then it happens from the center point. It takes a bit of practice, so we'll do more of it. Okay? Everyone clear till this now? This point? It will become clear as you try it out. So that is why we have a 10 gram activity. You all have done your 10 grams, right? Yes. So what we are going to do now is, have you got the file? Everyone, 10gram.kojo?
Yes, sir.
All of you have got it, right? Okay, so there was this one interesting question which had come up. I'll answer it. So, take a look at this, okay? See the border. See the border? Here? So I'll first remove this. Do you see the border? So it is thin enough, right? But let's say, what I'll do is I'll reduce the size of it. Okay? This is good enough. Now if I say this is 5 times, did you notice what happened to the border? That also got bigger. Because it's like you are watching it under the microscope. Everything appears bigger. If you draw something with a pen and hold it, the whole stroke of the pen appears bigger. That's exactly what is happening here. So how do we ensure that this does not happen? See, it is getting scaled by some amount, right? If the whole stroke was reduced by the same amount before it was scaled, you will not have this effect. Want to see how? So this is scaled by 5, correct? So let's give a stroke size. So let us say that's stroke size. What should we say? 2? Okay, this looks to be 2. Okay? What we would do is, before, see, we are scaling it by 5, correct? Before we scale it, we will reduce the stroke size by 2 by 5. Everyone getting it? Whatever, see, it is multiplication, right? Scaling is multiplication. So when you say that scaled 5, means you are multiplying whatever that value is with 5. So if you want this stroke, see, this size, this, right, this stroke size to be same when this is scaled to 5, you have to reduce the stroke size or divide the stroke size by 5. What is the stroke size here? 2. So that's stroke size 2 by 5. And then you scale it, and the stroke would be of its correct size. It's multiplication. You divide, you multiply, same amount, you get 1. Correct? So this was the question, so I answered. One more thing. pick stack. Let us do pick stack. Okay, so we have this with us. Let us do circle. Okay, we have a square which is fine. No, I'll remove this. Let's not have this complexity going on. Let's do a circle. Let's do a circle. And now I will do even an easier method of doing a circle. Okay. So what was the first method of, how many methods have we seen of doing a circle? So whatever we did in the morning, right? Forget it. Easy enough, right? That is why we did it in the morning, because in the afternoon nobody will listen to the difficult thing. So how we will do? We'll do a bigger one and then we'll do a shorter one. Okay? So depth circle is equal to picture. Alright? Depth circle is picture of what? We'll say right. Let's say radius to be 100. Sorry, angle, right? Full 360, correct? And this to be 100. Correct? So this is our circle now. So how will we draw it? After the square, we will say circle dot draw. And we have a circle. The only problem is its circle center is not in the center of the screen. How will we get the circle center in the center of the screen? Okay, so we are making life more and more difficult. So I will make it rather simple. We simply say picture dot circle and 100. Is it enough? You're directly getting everything that you want. You don't have to like really go and do the turtle bathing. Right? So I'll fill this circle up with that's filled with green. Okay? Now we have square and a circle, right? Now what I want to do is this. If I am rotating, right, the whole thing should rotate. And let's also draw a line which goes from this point to this point. How should we do that? We need a line. Depth. Line is, because circle rotation cannot be seen, so we'll put a line. Picture dot line, width and height. Right? So we'll first make it up and then we'll change the other direction. Right? So width is 1 and height is the radius. So if I say line dot draw, at the end of it, we should see the line, or should I just make it a little bigger? Do you see the line now? So obviously we'll have it translated, rotated. That's rotated. How are the rotations in Kojo? Anti-clockwise. So if I say rotate by 45, right, it will come this side. We want it to be this side. So minus 45. You see the line now? It's much more clear. Okay. Now what I want to do is, this is the challenge now. Okay. I have 3 pictures being drawn. And I want the whole picture to be rotated. How will I do that? Or I want the whole picture to be drawn, reduce the size and draw the whole picture here, here and here. How should we do that? Yes. So if we can combine all of them and make one picture out of them, right? We can apply the same rules on all of them. So take a look at how we will do it. Okay? Before you combine everything in a pick stack, remove all the draws. So I'll remove this draw, I'll remove this draw, and I'll remove this draw. Now nothing is drawn. Okay? And then I will say def whole picture is equal to pic s tab, pic tab. Did you see that? Put a bracket. Okay? Put the bracket at the end. And then wherever the picture finishes, right, put a comma. Shift Control F. Now if you draw the whole picture in one draw, you have an entire picture drawn. And now if you try to rotate that, right? See, the whole picture is rotated with a single rotate command. So that's a fixed type. Lot of things in a very, very short time. Same way you said the whole picture, right? Whole picture itself is a picture.
How do you rotate it?
You say whole picture dot, that's okay. The thing about 10 gram, right, is you have got just 7 shapes. Only 7 shapes. The 7 individual pictures that come together to form one big picture. So, there is square, there is triangle 1, triangle 2, again triangle 2 we will see why, triangle 3, parallelogram and triangle 4.
Is it correct? There are 4 triangles there, one square, one parallelogram. Correct?
Those who are having trouble taking the diagram of Kojo file from WhatsApp, we post it in the classroom also. You can just, in case you have trouble opening WhatsApp, something like that.
You know the
So now this is the game. Okay. And I'll explain the game. Is it not open? Everyone has opened it? Okay? So, the code that you have, right, you'll have the first two, those second and third line commented out. You can uncomment it. Again, there is a shortcut for it. Click on the line, press Ctrl/. Or select both of them and press Ctrl/. It will uncomment. Okay? What you should do, right, is hold the shape that was given to you and we will mark each one of them. Okay? So you see the triangle one, square and all. We would write here which those shapes are. But you will figure out which one. Okay? Just take a look, okay? Size by we can easily figure them out. If you notice, right, these two triangles are same. These two triangles are same. Right? That leaves square, parallelogram, and this parallelogram. Okay? But we just need to mark which one is which. So, I am not going to tell which one is the square. So you can take a square and write a square on it. Too difficult. Then there is triangle 1. Can anyone guess which one of this is triangle 1? Actually these are same. Just that when I was conducting this last session, right? Last training, that was the time when it was originally written. And I didn't realize they are same triangles, so I wrote them twice. So that is why we have this triangle 1 and triangle 3 going around. Right? So triangle 2 here. No. Triangle 2 and 2 is this. Okay? So we'll mark them. So this one is triangle 1. Can you see here? It could be either one of them. Okay, by the way. Okay. That's the triangle 1. This that you see, these two bigger ones, they are triangle 2s. Okay? Triangle 3 and triangle 1 are same, by the way. Triangle 3 and triangle 1 are same. Okay? And triangle 4 is this one, the odd one out. Now you know which one is a parallelogram, right? So you can write parallelogram on it. Done? Now here is what we need to do. Okay? Individually, we need to build some shape. So how will we do one? Can I have one? Or I think I can. So which one should we do? This is the easiest one. Triangle or the fish? Which is the easier one? So I do one, but one side do fish, right? Everyone cannot do fish.
Then do dog.
Yeah, Shravan. But I'm fish found you, okay? So essentially, if you see, can you guess the shapes? Triangle 2, triangle 2. Okay? Can you see here?
1 and 3.
Triangle 1 and triangle 1. They are basically the same thing. Okay, square, parallelogram, and the last one, triangle 4. Okay? So that is what we need to organize now. Now if you see, right, so these two triangles are kept on an edge, at their particular edge which is there. Can you see that? They are all meeting up on their edge, so this shape gets formed. This square here is exactly at the center. So accordingly we can move these two triangles up and
The
down.
other two triangles are same as in the position of the triangle.
Yeah.
Can move all
Just
three
move.
together.
Correct. And then finally the parallelogram and the other triangle. Should we try? We'll quickly do one, then you do remaining. Not the fish. Okay? And just help me doing it. Okay? Don't try doing it because you will need to quickly do the other remaining ones. So let's quickly do this. We need to look at these two ones. Let's organize these two. Okay. What I would do quickly enough, I'll comment everything off. Okay. And control enter. Now nothing comes.
So what is that?
We'll talk about that. Ignore that for now. Okay. So we need triangle 2 and 2, right? We need these two triangles. The first two. Correct? Big one. So they currently appear like this. So one thing I understand is this blue one which is there, right? Correct? Should need to be rotated. Take a look at this, okay? Understand this. Do not try. You will miss lot of things. Can you see this line? I want to get this line here. The point is fine, but this line needs to be turned like this. Is that correct?
Facing this side. The fish is facing.
Rotating.
The fish will be facing this side.
Correct. So this whole thing I want to rotate now. Can I?
Will face this side.
This line. Or the other thing I could do is I can get this point here and then rotate it. Basically the same thing.
You wanted middle line on the x-axis, on the left hand side.
In the minus side.
This line, right,
Yeah.
is something we want.
No, fish facing this side. Fish facing this side.
Fish
The
facing
middle
the
line
other
on
side.
the x-axis, on
Which
the
one?
negative side.
This
Middle-
line?
Yeah.
So how should we do that?
Rotate the
Rotate.
thing
First let us rotate it here, right?
Yes. Then this.
So this is 45-degree rotation
So rotate 90.
and then 90. 90 plus 45 is.
135.
So what I would do is that is one thing I could do, or
So we could define this thing as fish mouth and rotate both the shapes together.
yeah. That's pretty. So that's rotated, right? Both of them are rotated, and both are triangle too. So let us first try to get this first one going. Correct? This edge which is there. Or let's stabilize them first. Let's just stabilize them, correct? How do we do that? We'll rotate both of them by 45 degrees, negative 45. Okay? That's rotated minus 45. And then this is 90 minus 45. See, I am not calculating. Okay? Now I am going to do something very interesting. I want the fish to be looking this way. I want it exactly the way it's been shown, right? But I am not going to rotate the whole thing. I am simply going to say that's flipped. Sorry, with. Dot with flipped x or y?
X.
With flipped x, correct. Correct, and similarly here, both. with flipped x. Done? Now we want to have the square right at the center. There comes the square. So first we need to rotate the square. It's rotated this way, right? It's rotated by around 45 degrees. So we'll rotate it by 45 degrees. So we will say that's rotated 45. So there you have a square. Now we have to move it exactly up by half the square. So that's translated. Now what is the size of the square? So, some Pythagoras theorem is involved. Size of the square is 1/4 of the diagonal. Is it 50? No. 100? No. Looks like nobody cleared Pythagoras theorem. Even I did. But there is a better way. Like, this is not a Pythagoras theorem class. Okay? So, and we don't also want it to be a Pythagoras theorem class. So, we'll ask Google. Diagonal of square of size 200. Okay? And then it's going to say what is the, what is the side A? 200. 200. Okay? So the diagonal is 282.84. Okay? Now what I'm going to say is again ask Google. 1/4, right? Why 1/4? This is the whole diagonal, correct? This is half of it. This is half of half. That is 1/4. Okay? 4. That is 70.71. So this, okay, this side, right? This side is 70.71, and we have to move it up by half of 70.71. I'm not going to calculate all that. So 70.71 divided by 2. Okay, and this is going to be 0. Oops, sorry. Other way.
Why?
0, comma, and I'll remove the other 0. Is that correct? Now, let us focus on triangle 1. Where is triangle 1? So what should we do with this triangle? Right? The whole problem with this triangle, right, it is already translated. So let's remove this entire translation. Do not remove the comma, okay? Or the safest one, right? If you don't want to mess up, just say 0, 0. Removing is dangerous. God knows what will remove. Right? So that is where the triangle is. So we have to rotate that triangle. With flipped bottom. And remember, okay, the rotation happens from the center. So if I now rotate it, this point will remain common, and we rotate this by minus 45. Okay? So I'll keep that translated as is. But before that we can say that's rotated by minus 45. So it's this way now. We have to shift it down. By how much?
Minus
71 divided by 2. Exactly this distance, correct? So here that's translated, right? Minus 70.71 divided by 2. There. Okay? Now we have triangle 3, which is same. What should we do here? We rotate it the other way around. Correct? So first minus 45 and then minus 90.
But the green one is not done.
Green one is down, right?
No, still it has to come
It has to be
back.
done.
Oh, it is the other way round.
It has to come back and corner.
No, I flipped it the other way around. Sorry, let's
Yeah,
forget this one.
it's not.
I flipped it the other way. My bad. So this is what? Triangle 1, right? So let's make this 0 again for now. No, this is not how it should have been, correct? It's wrong rotation. So what's the correct rotation?
40.
So if I
45.
45. Oops. See, always double click and select it. 45. This, are we going to move down? No.
Yes.
Now it's
Down.
Go down.
Not down, right?
Go down.
Down.
Down by 70 point.
minus
70.
x minus 70. Minus 70.
Wait, huh? So, is this correct now?
Yes.
Yes,
I
yes.
just have to
Ah,
come
yes,
down.
correct.
Minus
Correct.
70.
Yes. So this is by how much now?
Minus
Full. Correct. Minus 70.71
Divide by.
divided
No, correct.
plus into 1.5 into 1.5, right? Into 1.5.
by 1.
1.5, right? See, think of it this way. This is 70.71 into 1, right? So we moved it entire 70.71. How much is this? Half of 70.71, right? So one whole 70.71 plus half of 70.71. That is 1.5. Now what should we do about the other one?
Firstly, where it is.
Other one is actually simple.
You can't see.
We can't see.
What?
The gray one.
Because I have uncommented it out. But probably we don't need that. If I just take this triangle 1 and say with flipped y,
Yeah.
does that solve a problem?
Yes.
So I'll copy this whole thing, paste it, and towards the end we'll say with flipped y.
The translate will be different.
Is that correct?
Yes.
Yeah? Now comes the parallel. So we don't need which? Triangle 3, right? So now comes the parallelogram. Where is the parallelogram? It is there. We don't want that, right? What do we need?
We need to flip it.
Correct. So first, let's flip it. But let us remove the translation also to start with. Okay? This is how it is. First, let us flip it.
Flip 10, 10.
Correct? So, parallelogram with flipped x or y?
Y.
Y?
Y.
Is that correct?
Yes, sir.
Now rotate it by
90. No.
45.
45.
Now move it
A little down.
down,
Half. One.
half of 70.71.
Yeah.
So that's already here. Minus 70.71 divided by 2.
And x will be 70.70.
And x would be 70.71. And then final one. Triangle 4. Triangle 4, I'll remove the translation, okay? It says the same thing, right? Remove the translation. Okay, so this is how it looks like. So what should we do?
Rotate by 45.
Is it rotate by 45 or should we? Okay, so let's rotate it. Okay. That's rotated 45. Next,
X, translate X,
x by how much?
70 point.
How much is this distance?
That is 70 point something.
First translate and then rotate.
No, these are not all equal sides, right? Yeah, they are equal sides.
70 point.
70 only
Or is it
done.
100?
Plus
70 point
The
something.
diagonal is 70.70.
diagonal.
Sir,
One square.
Diagonal is 70.71 into 2. This diagonal is 70.71 into 2. This is 100. This is 100. This is what? .71, correct. This is 70.71. So we move it by 70.71. This will come here
into 2.
into 2, correct? So 70.71 into 2 and down by
0.5
of
of 70.71.
minus 70.71 into or divided by 2. There you go. Once done, comment out these two lines and run the code again. That's the fish.
Okay, I would like to thank Anay sir for spending one more day with us. Thanks, Anay sir. Thanks to our team, the back office team who is working hard to make all this possible.